Hi, it's Jen and welcome to my channel, and in today's video I'm going to be talking about the neuroscience of bipolar disorder. Bipolar disorder is probably the disorder that I'm the most interested in understanding the neuroscience of, but it's taken me some time to find the right review article that really made a lot of sense to me and to be a good place to start understanding the neuroscience of bipolar disorder. So I hope that it's really helpful for you guys too. So bipolar disorder consists of periods of depressive lows and manic highs. So depressive periods can consist of having a lack of motivation, staying in bed longer, and losing pleasure in things that used to bring you joy, whereas manic episodes can include periods of higher energy, not needing to sleep as much, and sometimes losing touch with reality. And it's important to note that suicidal thoughts can come up during depressive episodes as well as during manic episodes. So I will post the review article that I found the most helpful in the description below. And the title of it is A Critical Appraisal of Neuroimaging Studies of Bipolar Disorder Toward a New Conceptualization of Underlying Neural Circuitry and a Roadmap for Future Research. So this article found three themes of the neural circuitry of bipolar disorder that relate to emotional regulation, and in this video I'll be breaking down those three themes for you. And while this video will be discussing the differences between bipolar disorder from healthy control subjects, my long-term goal is to understand treatments for bipolar disorder, so I really find understanding the neuroscience of mental health disorders to be empowering rather than deterministic. So this is just a starting place for understanding the neuroscience of bipolar disorder, but the long-term goal is to find treatments and that makes sense for this neural circuitry. So the first theme is that there are frontal amygdala connectivity alterations during emotional downregulation in people with bipolar 1 disorder. So to clarify, bipolar 1 disorder consists of depressive phases and manic phases, where bipolar 2 disorder consists of depressive phases and actually only hypomania, so they don't reach full-blown mania, but rather just like the lesser symptoms of it. So that's just a distinction between bipolar 1 and bipolar 2. And most of the research that I'll be talking about today is about bipolar 1 disorders, so patients who actually do have a manic phase. So as I mentioned, this first theme is about emotional downregulation. So the task used in this study for emotional downregulation is they used an image like a snake, and the subjects would look at the image and then they would tell themselves something like, "This snake is not poisonous, it can't hurt me." And that is supposed to downregulate the emotional response to seeing this image. So the subjects all did this task while they were in an fMRI machine. So they were able to look at the activity of the areas of the brain while doing this task. So this image shows that there was greater activation of the ventrolateral prefrontal cortex for control subjects versus the euthymic subjects with bipolar disorder during the emotional downregulation task. So this study included subjects with bipolar disorder 1 who were in a euthymic state. So they were stable, they weren't in a depressed phase or a manic phase during the study. And then this image shows the connectivity between the ventrolateral prefrontal cortex and the amygdala. They found that there was significantly greater negative connectivity between the ventrolateral prefrontal cortex and the amygdala for the control subjects than there was for the subjects with bipolar disorder. So this means in control subjects, when the ventrolateral prefrontal cortex is active, the amygdala becomes less active. So that's a negative correlation, whereas in bipolar subjects, it's not as negative. So this could imply that the ventrolateral prefrontal cortex is not controlling the amygdala in subjects with bipolar disorder as much as it is for control subjects. So to summarize, not only is there a greater negative connectivity between the VLPFC and the amygdala for control subjects, but the VLPFC is also more activated for control subjects than it is for bipolar subjects. So this means the amygdala is much more active during emotional downregulation in bipolar subjects than it is for control subjects. So this would imply that the emotional downregulation was less effective because there is still more fear in response to this picture of a snake for bipolar subjects than there would be for the control subjects. The second theme is that there is abnormal activity in emotion processing circuitry depositive of the emotional stimuli. So one of the studies that explores this theme looked at how control subjects versus bipolar subjects responded to different types of emotional faces. In this study, they were shown different types of fearful faces and different types of happy faces. And so for each group, there was like 20 neutral faces that weren't fearful at all. Then there was 20 faces that were 50% fearful, and then 20 faces that were 100% fearful. Same for the happy faces. There were 20 faces that were neutral, 20 faces that were 50% happy, and 20 faces that were 100% happy. So this study found that for the bipolar subjects, there was a greater activation in the amygdala in response to positive faces than there was for the control subjects. So the authors of this study concluded that there was a reduced regulation of the amygdala in response to this positive faces, and this could be a predisposition for manic episodes for people with bipolar disorder. The third theme is that there was abnormal activity in emotion processing neural circuitry during performances of non-emotional tasks. So the non-emotional task in this case was called a go versus no-go task. So basically, for every letter of the alphabet, you would use your right thumb and press a button, except for the letter V. So the no-go task was V, and every other letter besides V was the go task. This study actually had 2 different bipolar disorder groups and 1 control group. And the different bipolar disorder groups was that there was one group that was by people with bipolar disorder who were experiencing mixed episodes, and one group of people with bipolar disorder who were experiencing just depression. And a mixed episode means that these people are feeling depressed and manic within the same day. So this study actually found that there was greater activation of the VLPFC, the OFC, and the amygdala in the subjects with mixed bipolar disorder as compared to those with depression, as well as compared to the control. So it's interesting because basically these people with mixed bipolar disorder are activating all of these areas of the brain that are related to emotional regulation. However, it's a non-emotional task, so it's different that the ventrolateral prefrontal cortex, the OFC, and the amygdala are all becoming activated during these non-emotional tasks for people with mixed bipolar disorder. So this suggests that they are having more emotional salience for this non-emotional task than the group with bipolar depression and the control group. Another study was looking at motor response inhibition, which is again another non-emotional task, and subjects with mania had increased amygdala activity than did subjects who were control subjects. So it's important to note that mania and mixed episodes have a more emotional salience for non-emotional tasks than for people who are euthymic or depressed or control subjects. So these 3 areas that have different emotional processing for bipolar disorder versus control subjects include the ventrolateral prefrontal cortex, the orbital frontal cortex, and the amygdala. And in order for you to remember these areas, I'm going to summarize the general use of these areas so you can integrate that into what we've talked about today. So the ventrolateral prefrontal cortex is a region of the frontal lobe that is typically associated with response inhibition and goal-appropriate response selection. The amygdala is commonly thought to form the core of the neural system for processing fearful and threatening stimuli, including detection of threat and activation of appropriate fear-related behaviors in response to threatening or dangerous stimuli. And the orbital frontal cortex is a prefrontal cortex region in frontal lobes of the brain, which is involved in the cognitive process of decision making. So there's, of course, a lot more neuroscience research on bipolar disorder, so I will hopefully come back with more and more information. And if you have any questions or want to know more or have like a specific request on a neuroscience video about bipolar disorder, please leave it in the comments below. If you like this video, please like it, and if you want to see more from me, make sure to subscribe. All right, bye.